6.1, equation of a line in slope-intercept form. So y equals mx plus b. So last chapter, in chapter 5, I talked a lot about y equals mx plus b. So this is going to be more detail of what that means. And this is actually called slope y-intercept form. So lines have many types of equations. This is one of them. It is the easiest one, in my opinion. So let's take a look what this entails. So y equals mx plus b. The two things that we're interested in are the m and the b. We already know m is slope. So if you have to come up with an equation of a line, the slope goes next to the x value, because this is the thing that's changing, because x is the variable, right? So based on the slope, for every x value, this line is going to change by this constant number. Now the y-intercept. The y-intercept has a lot of names. It could be called the y-intercept, the initial value, the fixed value, the constant. Okay, so questions get difficult because these are the words that are in the questions, and you don't know how to relate it to the y-intercept. So if you know the y-intercept and its different ways of being visible in a question, it's just the number that goes over here on the outside. If this was a -5, it'd be -5. If it was a +7, it'd be +7. Okay, so the y-intercept is pretty straightforward. It gets a little tricky when we have to find it without a graph. But if we know the slope, we know the y-intercept, everything else is pretty easy. So I'm going to do an example here. Okay, so down here, this example, if the slope is -1/2 and the y-intercept is 5, find the equation. So when they're explicitly telling you what the slope and y-intercept form, this is very straightforward. Questions get increasingly difficult as the language of slope and y-intercept is converted into something else. Could be a word problem or anything else. And also sometimes we don't know what the slope is. This is telling us the slope is -1/2. Sometimes it can give us points and we have to just find out what the slope is. So everything in this chapter is based on this right here. This is just as easy as it comes because this is explicitly telling you what the slope is and it's using the word slope. Okay, so we know the slope is -1/2. So y equals -1/2x, and the y-intercept is 5 plus 5. Done. This is the equation of the line. We know our slope, we know our y-intercept, finished. Okay, let's go on to another question that's a little more difficult. Okay, so I know I didn't discuss graphing in too much detail besides table of values, but if you have to graph something in slope y-intercept form, this is really, really simple, especially if we have the equation. I'm going to show you how to do that. So if you have slope and y-intercept form, you know slope, you know y-intercept. When you graph, you start with the y-intercept. Why? Because this is the only thing you know for sure right away. You know that on the y-axis, this equation starts at 5, right? This is 0. So the y-intercept is always the first thing you plot. This is +5. If it was -5, I'd be plotting it down here. Now, from this point, I'm going to use my slope, rise over run, to figure out a bunch of other points. So here, my rise is -1, and my run is 2. So I'm going to go down 1, over 2. So this is 1, this is 2, this is 3, this is 4. This is 4, 3, 2, 1. Okay, so I went down 1, over 2. And I'm going to keep going. Down 1, over 2. Down 1, over 2. I can keep going. Really, I only need 2 points to create a line. I get my ruler, and I draw a line through all the points that continues from one end of my graph to the other, with arrows on both ends. If you don't put arrows on both ends, it's not fully correct, okay, because lines go forever. Okay, so again, you plot your y-intercept, really easy, whatever the b value is, and the hardest part is the slope. I look at the slope, it's always in the form rise over run. So I'm going down 1, -1, over 2, plot a point. Down 1, over 2, plot a point. And you can keep doing this, keep going forever. Okay, and that's it. That's how you graph. Really, really quick. 1 point, rise over run, connect the dots like you're 4 years old. Okay, next I'm going to give you some exceptions to some rules. So horizontal lines and vertical lines are special cases in terms of lines because the equations look a little different, especially the vertical line. So horizontal line is like this, and this is vertical. This is horizontal. Okay, now horizontal line that goes like this has a slope of 0. Technically, if you're skiing on a slope of 0, you are not moving, you're flat. So a horizontal line is a slope of 0. And if we have a slope of 0 and y equals mx plus b, when I plug in a 0 into this m value, it knocks this out. 0 times x is 0. So I'm just left with the y-intercept. So if this horizontal line, for instance, was going through the y value of 3, this equation is just y equals 3. So any horizontal line is just the equation y equals whatever y value it's going through, because it's going to go through that y value forever. No matter what the x value is, it could be 1,000,000, it's still going to be 3 in terms of the y value because it's a horizontal line. Okay, now vertical line is just going to be the opposite. If I have a vertical line going through an x value, and let's say that x value is -4. The equation for a vertical line is x equals whatever x value that is, -4, and that's it. Okay, I'm going to talk about slope for a vertical line. It's a little different than a horizontal line. This is a slope of 0, and everyone's going to be inclined to say 0 as well over here, but this is actually an undefined slope. Take a look at one point to the other. If I'm going from one point to the other, I have rise, but my run is 0. So let's say my rise is 5 and my run is 0. I can't do 5 divided by 0. This is undefined. Okay, so slope of a horizontal line is 0. Slope of a vertical line is not 0. It is undefined, as in we actually don't know what the definition for that is. Okay, you could think of it as teleportation, right? Because if you're skiing on this, I mean, you'd be teleporting, really. You'd be falling. On Earth, you'd be falling. In theory, you'd be teleporting. So horizontal lines and vertical lines have slightly different rules, but they're actually easier because there's nothing to do. You figure out it's a horizontal line, done. You figure out it's a vertical line, done. And that's it. That's vertical and horizontal lines. 6.1. Okay, and lastly in 6.1, just some language to come up with, how to describe certain relationships. So I made a little chart over here, math mark versus Warzone hours. And I'm going to create a kind of trend here that I don't know if this is the trend, right? But this could be a bunch of data that I've collected, and these are all the points that I just made up. So the general trend you can see is downwards, okay? Even though there's an arrow going up because lines go forever, the trend from left to right is negative. So how do we come up with something to say? So I always start with the x-axis first in my sentence, and this is how I write it. I say, as the x-axis increases, so as Warzone hours increase, now I always start my sentence with the x values increasing, always. And then whatever happens to my y values, this is what tells me what kind of relationship this is. So I go, as Warzone hours increase, math mark, what's happening? Well, it's decreasing. So as Warzone hours increase, math mark decreases. If the second word here is decreases, you have negative correlation. Therefore, negative relationship, negative correlation. Okay, so this right here is a great description of what's happening here. As the x increases, what happens to the y? Y decreases. If this decreases, that means it's a negative. If it were to increase, it's positive. Okay, so understanding the negative and positive and what it means in the actual word problem is pretty important. And this is a good kind of starting point of how you can describe it the same way every single time and be correct.